Welcome to SERVOsoft, size-complete servo systems. This tutorial highlights SERVOsoft's power and flexibility in creating complex dynamic loads. SERVOsoft provides three methods to create motion profiles with dynamic loads: thrust steps, importing from a file such as a text file or spreadsheet, and thrust formula. We will begin with a brief overview of thrust steps. Thrust values in a move are defined in steps, where a thrust value is specified for each segment: acceleration, constant velocity, deceleration, and dwell. For example, let's take this move, which currently has no thrust. I'll add the thrust values for each of the four segments and click OK. Here's the thrust profile, now showing the four thrust steps, one for each segment of the move. In most cases, thrust steps is a suitable approximation. However, sometimes an engineer really wants to examine how the thrust load changes with velocity and position, and how that affects the entire system. Let's look at importing a sequence from a file with a complex thrust load.
In our example, we will import just 240 segments from Excel, but you can have up to 10,000 segments.
So, let's start with a blank sequence and open the import sequence form.
The data can be in several formats, including time and velocity, or time, velocity, and Excel, and we can add three more columns for payload, thrust, and torque so that they can vary with each segment. Up to 10,000 segments are allowed, providing a high level of resolution of load changes during a sequence.
Let's look at an example using a simple formula where the thrust load varies proportionately to the square root of speed times a constant.
In this spreadsheet, we have 5 columns: time, velocity, inertia, thrust, and torque.
In this example, the inertia does not change with velocity, so we have used a value of 0 for all segments. Our thrust profile uses the formula shown in this cell, which is a function that varies proportionally to the speed squared times a constant. In this case, the constant is 900 Newton meters and the maximum speed is 300 RPM. The same formula is used for all cells in the thrust column. Next, we import the data into SERVOsoft. I will select time and velocity with payload and thrust to match our table. I will then copy the data from my spreadsheet and paste it in our import sequence form. We verify the appropriate units are selected and then click OK. Here's the sequence showing the velocity in the top chart, the thrust load in the middle chart, and the motor torque in the bottom chart. Notice how the thrust changes over time with each segment. Let's zoom in and take a closer look at the thrust profile. The individual thrust segments are clearly visible as steps. The sequence consists of 240 small segments. And here's the sequence in the motor performance chart of torque versus speed, clearly showing 240 segment steps. Now let's use the thrust formula feature in the same application. We can create the same load profile, but much more elegantly specifying the thrust formula directly in SERVOsoft. Here's the sequence showing the velocity in the top chart, thrust load in the middle chart, and the motor torque in the bottom chart. Currently there is no thrust load, so I simply open the move and enter the thrust formula. Note that I can right-click to get a list of profile variables, math functions, etc. that can be used in the load formula. Now here's the sequence showing the new thrust load formula in the middle chart and the new motor torque profile in the bottom chart. And the sequence looks like this in the motor performance chart of torque versus speed, clearly showing a continuous thrust load profile for each segment in the move: accel, constant velocity, decel, and dwell. We have just covered one very simple yet powerful example of the thrust formula feature. Use the thrust formula feature to create and model virtually any load that can be defined as a formula. The thrust formula feature is clearly defined here in the help file. And these profile variables can be used in a formula. Many math functions and constants are also available to be used in the thrust formula and are clearly presented in the help file. This concludes the SERVOsoft tutorial on creating complex dynamic loads. Thank you.